right. Hello, everybody. We are on the 6th lesson of our trig unit, which is our last lesson of our trig unit, and it's going to be about the Pythagorean identity. But first, let's look at this do now. So this do now says if theta is an angle in standard position and the terminal side passes through a point, find the exact value of tangent of theta. So the only real information they give us is that there's a point that this angle should pass through. So let's take a look at where that point is on our coordinate plane. So the point 2, -1. So we have 1, 2, -1. So the point is around there. Okay? So when you have a point and you're trying to find a trig value, you want to have a triangle in there. So you connect it from the origin to the point and then from the x-axis to your point. The reason why we are creating this triangle is because the trig functions such as sine, cosine, and tangent, those all come from a right triangle. Okay, let's label our parts of this. This distance here is at 2 because that is our x coordinate. This distance here is a 1. The reason why it's not a -1 is because distances can't be negative. Now to find the hypotenuse of the triangle, since it is a right triangle, we use a squared plus b squared equals c squared, which is our Pythagorean identity. So a would be the leg, so 2 squared plus 1 squared equals c squared. 2 squared is 4, 1 squared is 1, 4 plus 1 is 5, so 5 equals c squared. Square root both sides, square root and the squared cancel, and we get square root of 5 equals c. Now I know normally that when you do have the square root on both sides, you have two answers, a positive and a negative. However, since we are talking about side lengths of a triangle, we only take the positive answer. So now that we have everything labeled, the last thing we have to label is theta. We have to know where our angle is. Always start at your x-axis and then go to the hypotenuse, and that is our angle theta. So now we're trying to find the tangent of theta. To find the tangent of theta, we use SOHCAHTOA. Since we are looking for a tangent, what we care about is TOA, so OA is opposite over adjacent. The opposite of theta is 1, the adjacent of theta is 2. So last thing we need to check is if this is positive or if this is negative. To see if it's positive or negative, you use all. Students talk constantly. Since this is where the C is, that means that only cosine is positive, so tangent is negative. So this right here is our final answer. All right, going into what an identity is. An identity in mathematics is true for all possible values. Now, a trig identity is an equation that involves trig functions and is true for every single value substituted in for the variable. So we're going to figure out what our trig identity is today. It involves the Pythagorean theorem. So what we do here, Pythagorean theorem is usually a squared plus b squared equals c squared. So if we remember on the unit circle, x corresponds to the cosine of theta and y corresponds to the sine of theta. So we're actually going to use those two values for a and b, cosine and sine. So a would be cosine of theta, and we're squaring it. B would be sine of theta, and we're squaring it. And see, our hypotenuse is 1, so it's equal to 1 squared. Now you can see the identity written like this, or you might see it like this. Cosine squared theta plus sine squared theta equals 1. And that is our identity. So this is super important. Usually questions do give you the identity, however, not all questions will. So you need to know that this is the Pythagorean identity. If you would prefer to write it with parentheses, such as sine theta squared plus cosine theta squared equals 1, you may do so. It is the same thing. All right, so let's get into some problems using this. So this question says, given the sine of theta is 1 over 6 and angle theta is in quadrant 2, use the Pythagorean identity to find the exact value of cosine of theta in simplest form. So it tells us to use the Pythagorean identity, so let's start by writing it. It is sine squared theta plus cosine squared theta equals 1. Now, they tell us that sine of theta is 1 over 6. So for sine of theta, we are going to substitute 1 over 6. So you have 1 over 6 squared plus cosine squared theta equals 1. Now we just simplify and solve for cosine. So 1 over 6 squared, we simplify that by doing 1 squared over 6 squared. All right, and we still have plus cosine squared theta equals 1. 1 squared is 1. 6 squared is 36. And we still have plus cosine squared theta equals 1. What we're going to do next is we're going to have to subtract 1 over 36 on both sides. But I am going to move my work up here. So we had 1 over 36 plus cosine squared theta equals 1. So we have to subtract 1 over 36 on both sides. When you do that, you're left with cosine squared theta is equal to, now if you need to use your calculator, you can most definitely use it. You would be typing in 1 minus alpha y equals 1 over 36. And we get 35 over 36. So this is equal to 35 over 36. Now cosine is not by itself yet. We still have that squared. So we have to square root both sides. Now I'm going to square root the numerator and square root the denominator. So when we do that, we get cosine of theta equals the square root of 35 over the square root of 36 is 6. Now the last piece of information that we didn't use yet was that it's in quadrant 2. The fact that it's in quadrant 2, we have to use all students talk constantly. We're looking for cosine, and in quadrant 2, only sine is positive. So that tells us that our answer is going to be negative. So that's how you use the Pythagorean identity. All right, let's see another problem. It says, given that cosine of theta is radical 13 over 7 and theta is in quadrant 4, use the Pythagorean identity to find the exact value of tangent of theta in simplest form. So let's begin. It says use the Pythagorean identity, so let's start with writing it. So we have sine squared theta plus cosine squared theta equals, sorry, let me just fix that. Cosine squared theta equals 1. They tell us that cosine of theta is radical 13 over 7. So for cosine, we are going to plug in radical 13 over 7. And that will be squared. The rest stays the same. So we have sine squared theta plus that equals 1. Now that squared goes to the top and to the bottom. So this stays as sine squared theta plus, this becomes radical 13 squared over 7 squared, and that is equal to 1. And we have sine squared theta plus. Keep in mind, if you don't need all of these steps, you don't have to put all these steps, but I will be putting every step needed. That's equal to 1. Now, we have to get sine by itself, so our next step is going to be to subtract 13 over 49 on both sides. That will cancel out when we do that. And we are left with sine squared theta is equal to, you can type in your calculator, 1 minus alpha y equals 13 over 49. And we get 36 over 49. Okay, sine is not by itself yet. We do have to take the square root of both sides. So we square root sine, and I'm going to square root the numerator and the denominator. The radical and the squared end up canceling out, and we get sine of theta is equal to 6 over 7, because the square root of 36 is 6 and the square root of 49 is 7. Now, the question actually didn't even ask for sine of theta. It asked for tangent of theta. But this helps us a lot because the tangent of theta, oh, I don't know what I just did there. The tangent of theta is equal to sine of theta divided by cosine of theta. Now we know cosine and we know sine. So tangent of theta is equal to, we found sine to be 6 over 7. Now, since we have two fractions here, I'm going to write it with the division symbol instead. So sine was 6 over 7, and we're dividing it by cosine, which was radical 13 over 7. Now, since we are dividing fractions, we use keep, change, flip. So we keep this, change this to multiplication, and flip that last fraction. And then we simplify. The 7s will cross out, and we are left with 6 over radical 13. Now, let's say if you want to rationalize your answer. To rationalize your answer, I will do this in another color. So, to rationalize, you multiply the top and bottom by that radical. 6 times radical 13 is 6 radical 13. Radical 13 times radical 13 just becomes 13. The square root goes away. So now we have tangent of theta is equal to 6 radical 13 over 13. We're missing one piece of information. This is in quadrant 4. If we think back to our signs, to all students, hold on 1 second. Students talk, that S is not showing up there for some reason, constantly. We're in the fourth quadrant. The fourth quadrant is where C is. C means only cosine is positive, and since we have tangent, that has to be a negative. So this here is our answer. Let's get another example in. So it says, using the identity, this problem, it actually gives it to you. It says, find the value of sine of theta to the nearest hundredth if cosine of theta is 0.77, and we are in quadrant 1. So they tell us to use the identity, so let's start there. So we have sine squared theta plus cosine squared theta equals 1. They tell us that cosine is 0.77, so for cosine of theta, we are putting in 0.77, and we're squaring it. Now we have to find 0.77 squared, and that is 0.5929. So we have sine squared theta plus 0.5929 equals 1. We are solving for sine, so we have to subtract 0.5929 on both sides. We're left with sine squared theta is equal to, bring it to our calculator, 1 minus 0.5929, and we get 0.4071. Last step to solve for sine is we have to get rid of the squared, so we have to square root both sides. The square root and the squared cancel, and we get sine of theta is equal to, let's figure out what this is, the second square root, second answer, and we get this big long decimal. I'm going to stop it there. Now, it said round to the nearest hundredth, so the nearest hundredth is the second decimal place right over there. So we have to look at the 8 in order to round it. Since the 8 is bigger than 5, that 3 turns into a 4. So we have sine of theta is equal to 0.64. And lastly, we have to figure out if it's positive or negative. It tells us that is in quadrant 1. So in our all students talk constantly, in quadrant 1, all of our trig ratios are positive. So that tells us that this should be positive as well. Okay, number 4 is very similar. We are finding the tangent for this one. So if you would like to work on this one, I suggest practicing it. Okay, to get credit for this class, you must complete the check for understanding question on a separate piece of paper. You must take a picture of your work and post it on to the assignment on Google Classroom.